Well, good day to you, my dear friends. Today it's very loud here. I think I have a hurricane outside. It's a bloody pandemonium, and I have a very loud roof. It makes all kinds of noises, but I don't think I will have a better opportunity to stream today, so we are going to solve some LeetCode problems despite of all these weather conditions, And where is it? Let's start with the problem, Jesus H. Christ, from yesterday. It's a Ruby problem. Final prices with a special discount in a shop. What was my last submission? I think... No. This was, yes. That's where we ended yesterday. Where we stopped. Let's check it. So, a quick reminder what we want to achieve here. So we have an array of prices, and we want to construct a new array of new prices, but with a discount. What is a discount? For each price we take all elements with bigger indexes, and among these elements with the bigger indexes we look for for those that are smaller than our element. So in our case all this will do. 4, 6, 2, 3, all are good, but among those we will choose the one with the smaller index, so we will choose 4, and it's going to be our discount, and we subtract this discount from our original price and we get the new price of 4. Now it's very hard to explain these conditions and rules. Sometimes it's harder to understand the rules than to solve a problem, and we ended with this solution yesterday. And like the only thing I can think of how to simplify it is just to move AND statement here, and we do not need AND here. So like this, it's a little bit shorter. I mean, we still break, and if we break then we won't be here, we won't get to this point after a break, of course. And even if we do, we don't really care that much. Let's test. Nice. But let's investigate solutions by other people. And there are many solutions, but for Ruby there are just 3. And I have issues with each and every one of these solutions. Let's start with the first one. Well, it's a similar approach. Yes, here we have 2 pointers, like left and right. But it's the same thing really. It's just instead left we have like price, instead of right we have starting index. Oh, it's better to say that instead of left we have an index, of course, not a price. And there is a while loop, but here we increment not only starting index, but also we increment left, but we do this automatically here when we iterate through prices, so I do not know why this is a better solution. It looks a lot bigger, it has all these extra variables, and it puts results in a result array, so it's an extra array, and it's not very good for space. So I do not really like this solution, but it's a two-pointer, you know, it can demonstrate you a good practice, not a good practice, but one of the algorithms, because two-pointer is a, famous, two-pointers is a famous algorithm. The problem is it's not usually too good, but still we use the same approach. So our approach is not that good. It's not that good either. I just can't come up with something better. Let's see some other solutions. This one, well, it's a short one, so I like that there are just 3 lines in this iterator, but on every step we create a new array based on our prices array. On each step a new array is created. I think it's a bad thing to do, because creating an array based on the original one but minus the first element, it's bad in terms of big O, But after we create this new array with lesser number of elements, we run find method. And we find a discount, or if there is no discount, we assign 0 and we return price minus discount. So it's all good. And the last solution. What do we have here? Well, it's very similar to mine, but here we do not iterate through our prices. We iterate through this range, but we still iterate through something. So what does it matter if this is a range or if this is an array? It's nothing, because taking an element from array by its index, it's a O1 operation. And here we take a number and then we take an element from prices by its index. So it's the same thing, actually, just a little bit more confusing for my taste. So it's practically the same. We do not need to return prices here. Oh, no, we do need to return prices here, because we do not iterate on prices. So I do not like either one of these solutions, so maybe I should upload my own. But this solution number 2, let's see it again with map. What if we, instead of each with index, we use map with index? Then we do not need starting index anymore. We can just do index +1 here, and of course here as well, and here as well, and here we want to increment index. All right, and here we want to rewrite our price, and in the end we want to return price. Hope it's not very confusing. Yeah, it's great. Let's submit. Great, so it's a little bit better probably than my previous solution because we do not have this extra variable starting index. It was a confusing one because it was starting index, but also it was all the next indexes too, because it was incremented. In terms of length, well, now we need to return this price, so we lose one line here, but we add one line here, so it's the same in terms of lines of code, of number of lines. The problem is I do not know if this is a best solution because there are so few of them here in the solution sections, and I tried to look for solutions in other languages. Like let's try this one, Python 3, 1 pass O n. Well, what do they do here? They still iterate through prices, but then they create a stack of indexes, and then they iterate through stack of indexes. Not indexes, how do you say it? Indices. So it's not really ON. I do not understand why it has such a high rating. Maybe I just don't understand something. And this solution also uses a stack, and we iterate through this stack. So it's the same thing. Well, we iterate through stack of indexes, then we use this index to take an array, to take an element from the array. It's the same thing. I do not know why this is better, and why they say that they iterate just once. It's not true. It's not just once. And you see there are many complaints about this. Please explain the time complexity, how it is n. No, it's not. You have nested loops for and while. How is it a big O of n? Maybe I just don't understand something. If you understand why this is big O of n, please write a comment somewhere, anywhere. Well, I think I'm going to upload my solution a little bit later. And now let's continue with another problem. This problem I solved I think a few days ago. Well, what I want to say is that I solved it before I started streaming, or something like this. Maybe I already started streaming, but still I solved it not live. And I want to go back to this problem because, well, it is solved. It will be nice to discuss this problem, to get a better understanding of it. Let's sort all problems, all easy problems, by acceptance, as we usually do. And we already discussed this one and this one and add to promises. By the way, let's go back to add to promises, because I promised you yesterday to explain promises better. Let's go back to my original solution, this one, for a starter. The way I return promises here, it's not like an optimal way, because we create a so-called callback hell. because we have one callback inside another callback. And what we really want to do in such situations is to return return a callback here, and then we want to use then not inside previous callback but outside. The problem is it won't work because now we do not have result 1 here. And that's a problem. And the only way to solve this problem is to introduce, some kind of variable. Let's call it res1. And here we do not only return promise 2, but also we set res1, we assign result 1, and here we use res1. Like this, it should probably work. Yes, it's all good. Because otherwise we call one promise inside previous one, and it's so-called callback hell. And this syntaxis of using thens and returning promises, it was designed to avoid callback hell. But in order to avoid it, we need to introduce a new variable, so it looks ugly. One way or another, it looks ugly. That's why async, is so much better. When we just use async, it does the same thing without all these complicated syntaxes. Oh no, async, not async, of course. Wait. Like this. But also we discussed, let's go to our submissions. Promise all. And I wanted to explain to you the difference between promise all and all the other solutions. Wait a second. Yeah. By the way, when we use reduce, there is a different order of parameters. First, it's how do we call it? Accumulator, and then this is a value, like this. It doesn't matter in our situation because we just add, two things. The order doesn't matter here, but just know that first goes the accumulator and then the value. And now let's go to paint, of course, because there is no better way to explain things than draw them in paint. Wait a second, I have a message. Great. Do you see paint? Yes, you see paint. Great. So imagine that we have, let's say we have a promise. It will be promise 1. No, let's just type it. Promise 1. And in our two solutions, my huge one with two promises run one after another, and in this await situation, how does it work? The first promise launches, you know, and only when it is fulfilled after some time, the second promise is fired. And of course, it also has some time limit, and here we get the result. When we use promise all, these two promises, they don't run in parallel because nothing runs in parallel in JavaScript. Instead of that, we call promise 1, and immediately after that we call promise 2, and this first promise trans and the second promise trans 2, so we end somewhere here. So they still launch one after another, but we do not wait for a previous promise to be fulfilled. That's why it's a better approach, and it will return the result after the last promise, the longest one, you know, is completed. So that's the difference. I hope it's easier to understand now, because I do not know how to explain it better. Okay, but let's solve some new problem now. Hey. Where are our problems? Houston, we have a problem. And as usual, let's choose easy. We start solving medium problems sometime this week, I think. I already solved them, but not live because I'm afraid it will take too much time. Oh, let's sort them by acceptance. I think we were at page number 4 already. Yeah. Remove palindromic subsequences. Jesus, it sounds awful. Oh. Accidentally closed it. Here it is. Oh, we have some awful solution. Let's immediately remove it. So you are given a string S consisting only of letters A and B. In a single step, you can remove one palindromic subsequence from S. Return the minimum number of steps to make the given string empty. It's not that easy, to tell you the truth. Okay, let's first of all I'm going to check if S is equal to S first. We will simplify everything later. I just want to get a better understanding of this problem. Else don't remember how do we call this method. Is it slice? Let's find out. Maybe string slice. Yes, we have such a method. So we need a loop while don't need this anymore. Jesus, the weather, it's crazy. Something like this. But still we have a problem. Let's run it. Of course, we have an endless loop. Slice. Oh. It's square brackets. Still it doesn't work. Oh, of course, we do not need slice. Just do it like this. Let's test it again. Still it doesn't work. A1, 2. -1. I just don't remember. Oh, of course. Great. Yes, that's what I was afraid of. awful. But for now it will do. No, not like this. I think we need counter here. Here we return the smallest of two counters, but it's an awful solution. Oh, it's bad. I don't know. I'm so not sure about this. Yeah, of course, it's just 0. Expected 1. Oh yeah. It's 4. Why is it 4? Let's think. At first we start here. We drop here. And our counter became 1. And S1 equals BB, and S2 equals AB. And we call this here is BB, here is 1. And what do we get? Yeah, I see a problem here. No, I don't. I don't actually. Okay, let's continue our investigation. We call it here, and it's a reverse. So we return counter plus 2, we return 2. So counter S1 is 2. And here we get something like this. It's A, B, and 1, and it doesn't equal to reverse. So our counter becomes bigger. Oh, I think I see a problem. Not 3. But because this time we do not want to +1 it. dirty trick. I just want to solve it already. Oh. So this is not a problem. Okay, let's see. A, B, and 1. We got a counter of 2. And we have a new S1 here. So this new S1 is just B. Wow, and we have a problem with S2 here. No, it's not a problem. It's going to be B also. Yes, but counter it will become bigger. It will become 3. Oh yeah. Well, okay, it will become 3, so what? Here when we compare 2 to 3, we are going to return 2, and then we plus 1 it, and it becomes 3. I so don't want to do this. And it won't even work probably. Oh god, it's the ugliest thing I wrote in my life. Oh, and it doesn't even work. Wait. Let's just start with 1. It's going to be a lot better. I'll put 3 and we want to have 2. Oh, it's even a bigger problem. It's an awful problem. Because here we want to take not just B, but B and B, and then ABA. But how can we distinguish these two cases when we want to take just one letter from the end, for example, or two or three, or if this letter is needed here? Well, if it is needed here, then we will catch this. In our first check, you know. No. No, we won't. Oh boy. Oh god, it's awful. Oh, I'm missing something. There is some trick to it. I just need to discover it. I just need to understand the trick. Because it's an easy problem. Well, I'm sure it will arrive like sometime later when I'm doing something completely different. It will strike me again, or when I'm trying to fall asleep. Jesus, I always think about programming and about LeetCode problems, and I just can't sleep. So maybe I will invent something in the night. Mhm. It's like we want to check every possible combination, but it's a crazy thing to do. We definitely do not want that. Okay. Yeah, I know. We shouldn't take just the first, skip just first character. We should skip the whole palindromic part. So, unfortunately, it's about time for me to go, but it's so bloody interesting. Count repeat letters and equals 0, and while s such a bad. Okay, we'll simplify everything later. Well, obviously, we do not have to use index at all. We can just use this beast. Here we want to use count repeat letters, and the same thing we want to do starting from behind. But of course here we already here we do need index, unfortunately. Or not. Of course not. We'll see about that. So can do like this. Oh no, no, no. We can't do it like this. Oh, we can. So hard to visualize. It's easier just to check it. Also -1. Something like this. Oof, it's awful. Let's run it. Of course. Yeah, because we do not have index anymore. Here it's simple, just -1. Still 3. Where is the mistake? -1. Oh. Do it like this, because we use minus here, become -2 and so on and so on, but here we want to use minus. Oh, fuck. Oh. Well, yes, this is a problem. Of course, of course, of course. Yeah. Because here it's this thin. So we need to check if this whole thing is palindromic somehow. Okay. Oh boy, oh boy. Nope. Let's do, first of all, do like this. No, just one. Just one. Else we're gonna do all this craziness. Of course, the same thing should be done here as well. Yeah, why is it one? Should be like this. No, this counter. I don't know what's wrong with it. This counter. Oh. It should be two. Like this. But it's three. How can it be three? Oh. Of course. It's awful. Just two? How? Let me think about it. Oh, right, it's BB. And then it's ABBA. No. I don't understand why this is 2 and not 3. What the hell? In a single step, you can remove one palindromic subsequence. Yeah. So. Is it a bad test case? It can't be true. Whoa. Whoa, someone is raiding me. Steven Code stuff. Unfortunately, it's not my most glorious moment, you know. But thank you very much. We can solve it only with the hive mind. Why? Why this is 2 and not 3? I just don't see it. Yeah, I'll have to think more. And for now we are stuck, because it's about time for me to go. But I'm not disappointed, you know. I was raided by Steven Code stuff with a party of 4. It's my biggest party. So thank you guys. Oh, and one more thing. Yesterday some guy visited my stream and he asked me to try his LeetCode alternative. How was it called? Algo Newbie, and I tried it, you know. And there is some story mode. I think you have Sir Array the Terrible, very Russian name, you know. And I tried to solve these problems, and I managed to solve all of them except for this find single. I think there is a bug. because let me find it. I'm sorry for a delay. I mean, my code is not pretty. Okay, but it worked. We can do this. Well, first of all, let's put it here. Looks like this. Let's try to submit. Nothing. See, what is the problem here? We want to find an element that is not repeated, the only unique element in this array. And I wrote not a very nice solution, but it should work. Let's test it in console. Let's add this method here. Yes, and let's call it like this. And let's console log result, although we are in console, so we don't need. Wait. Alright, right. 2. You see, we return 2. But why then do we fail this check? Huh? So this is a question for an author of this great project. Also, I hoped there will be some story development, you know, because when I beat this boss problem, nothing happened. Maybe I need to log in for something to happen, but I did not try to log in. So there is it for today, guys. I have to run. We'll come back tomorrow with new problems and I hope with new solutions too, but we'll see about that. So I'll see you tomorrow. Goodbye, good people of LeetCode community, I guess.